Welcome to Professor Babu Vishwanathan, who is professor in the Department of Mechanical Engineering here at IIT Madras. He has a very rich background of various things that he has done before. He has a PhD from Ohio State University in the United States. He has worked with Ford, so he has very good industry experience with one of the leading automobile manufacturing companies in the world. Here in IIT Madras, he has also been our placement advisor, so again a lot of industry interaction. He does a lot of active research in the areas of high performance computing and acoustics and propulsion. So these are all areas that he works on. So he has a very good experience with both industry and research. And so we are very glad that he could join us today and to discuss research in the area of mechanical engineering and various aspects that researchers might encounter through their stay here at, in their research career. So, Professor Vishwanathan, so we do have, mechanical engineering is a field that's been around for a long time, and in fact, I think whenever we talk of engineering colleges, that's the first thing that immediately comes to mind. Mechanical engineering is there, is one of the core areas that is there. So, what do you think?
Mechanical, civil, and
electrical
yes.
are
the three oldest branches
around. Yes, engineering. So, what do you think are, what people would think as traditional areas of research in mechanical engineering?
Traditionally, mechanical engineering department's activities can be divided into three verticals. One is the so-called thermal engineering. The other one is another one is the so-called design of components and other things, and the third one is the manufacturing. So these are the three verticals that you can divide mechanical engineering research into. The first one deals with thermodynamic aspects of design and things like that, energy conversion, energy conservation, and so on. The second vertical, namely design, works on the material aspects of equipment and devices. So once you have a design on paper that has been, let's say you are talking about an internal combustion engine or a jet engine or a compressor for a refrigerator, once the thermodynamic aspects have been looked at and the the requirements have been sized, then there comes the task of designing the equipment which actually will achieve those goals. If you, let's say you want to achieve a certain pressure, certain temperature and so on, you need to select materials which will be used to fabricate the equipment which can deliver these kinds of requirements. So that is the design aspect of mechanical engineering. The manufacturing aspect logically comes last, because having frozen the design, both the thermodynamic aspect as well as the materials aspect, now it is necessary for us to figure out how to actually manufacture this component. So far all these designs are on paper. You say you select such and such a material to make the piston rods or the piston itself and so on, but how do you actually manufacture them? So that may require special tools, special fixtures, special machines, special machining processes and so on. So that is the third vertical in mechanical engineering. So if you look at all three of them as a whole, it is end-to-end design. So you start from conceptualization, theoretical analysis, energy-based analysis and so on, followed by materials and followed by actual manufacturing details of the components.
Okay. So, of course, these, as you mentioned, are maybe what immediately come up as the traditional areas.
Correct.
So, maybe even in association with this or independent of these, are there certain areas that are considered modern areas of research which have come up maybe in, let's say, the last 10 years, which are associated with mechanical engineering that you think?
Mechanical engineering over the years, what has happened is two things have happened. One is even within the three verticals that I mentioned earlier, things have become very, very special. So if, for example, you look at an application like internal combustion engine, let's say diesel engines, the emphasis today, as you know, is on reducing emissions and pollution, and this goal is being pursued in many different fronts. One is, of course, to look at alternative fuels, which are better than hydrocarbon fuels in some sense. So people are looking at fundamental aspects of combustion of alternative fuels. There are also researchers who are looking at chemical kinetic aspects of combustion of such fuels with a view to reducing the emissions. So these are new areas. Now, furthermore, there are also researchers who are now who now have the capability with lasers and high-speed cameras and other devices. We now have the capability to actually take real-time pictures of what is going on in an engine, and then analyzing them to see whether something about the spray or other aspects, combustion aspects, can be optimized to reduce emissions. So we now have technology which can take real-time images of actual engines. So these are, so within each vertical there have been lots of advancements. And the other change that has taken place is many things have become interdisciplinary. Again, if you go back to the internal combustion engine example, if you look at an automobile today, everything is electronically controlled. Most of the things are electronically controlled, which means you are working with embedded systems. So people with backgrounds in electrical engineering are coming into mechanical engineering and vice versa. So these two things are happening. Research is becoming more interdisciplinary, and there are also developments within the traditional areas of research itself, things like mechatronics, things like nanotechnology, which is now being used in thermal engineering as well as in manufacturing also, to get desired finishes, desired quality of machining and things like that. So these are new things which have come into mechanical engineering.
Okay, very interesting to know. So when students come into the Department of Mechanical Engineering for PhD or an MS program, they do come there with background from a variety of different places that they have been at for their undergraduate engineering, which could be small towns, big cities, I mean well-equipped colleges, maybe some are new colleges and so on. What do you see are issues that they tend to face during their initial years here, or even through their PhD program, more specifically with respect to your department? Are there any specific things that they initially find that they are unprepared for, they need to get up to speed on and so on?
There are several problems that students from other colleges face. Typically over the years, that is what I have seen. The biggest problem that they face probably is the rigorous academic processes that we follow. Unlike other institutions, where for many different reasons things will not run in the sequence, in the rigid sequence that we follow. Where we have tests, evaluations, the exam papers are discussed in class, and some marking schemes are given to students. So the process runs runs in such a controlled fashion that students who are coming in for the first time into the IIT classroom they are surprised by when the semester, suddenly you face end semester exam and the semester is over. So it takes them a while to get adjusted to the academic process at IIT, where things are very well organized and structured, and we have very robust academic processes in place. Now this is particularly true of a department like mechanical engineering, because it is probably the biggest department on campus. Okay. So we have about at any given time, the department probably has about 1,800 students on roll, our department alone. So it is almost like a mini college, if not a college. So this actually can also be intimidating to students who are coming in, because the department is very big, and at IIT Madras particularly, the offices of faculty and labs are scattered all over the campus. So the department office is in one place, other things are in other places. So it takes a while for students to kind of get used to this geographic diversity of the department. And the other thing, as I said, is the academic process. Being a big department, we actually have, we need to have, and we do indeed have very robust academic processes, because that is the only way you can deal with such large numbers. Haphazard processes will lead to a lot of confusion, complaints, and unfair accusations of unfair treatment and so on. So we have very well structured syllabi, very well structured timelines, number of lectures for each and so on. And we also, in the department, as a department, we go through periodic reviews of our curriculum as well as our syllabus, to take into account new things that have taken place, and also to see whether, based on experiences, difficulties that students have, whether some bridge courses are required to make the transition easy for such students. So we do that also.
But in terms of, say, let's say preparation for research, is there something that students may not necessarily be even just coming to an IIT, but just their general preparation to face research or to pick up research in an academic setting in the area of mechanical engineering? Are there certain things that they are they feel less prepared for when they come in, and then they have to learn some things new in addition to just specific coursework?
Yeah, I mean, many of the students who come, they actually are not very clear about the areas that they want to work in. So that is one major problem for them. So they come here and then they are exposed to the rigorous aspects of the area that they have chosen, and that might perhaps be a little bit unsettling for them because they thought it was something else and this is actually something else. So that is one thing, and in that case we try to work with the students to see whether something can be made more interdisciplinary, the research topic can be made more interdisciplinary, or whether they can take courses in certain other topics also and work in areas which are suited more to their liking. So those are all done on an individual case-to-case basis between the guide and the student, and it is very much possible to pursue interdisciplinary research also. So we try to take that into account. Understandably, undergraduate students who come here for research, many of them kind of have likes and dislikes, but they are not really sure whether this is something that they want to pursue,
do research on.
To do research on. So they find out whether they are actually prepared academically to do research in this topic is something that they find out only after they come here. So, but that is understandable as undergraduate students. You know, you cannot really expect them to know everything. So we are prepared to work with the student so long as the student is open-minded and willing to, you know, make some changes and adjustments and so on. The department has always, you know, tried to, despite being so big, the department always has actually accommodated individual students' needs and requirements, and you know, made sure that, you know, they have a good experience while they are here.
Okay, so maybe since you were talking of you know, processes and procedures and, you know, systems in place to for students to have a good experience here, a bit of a mundane question. So some students joins here for or joins your group for a PhD. What is your opinion on, you know, how often a student should you know, meet their advisor, spend time with their advisor? That's an interaction that's always there, inherent in this kind of a setting. What do you think are your views on, you know, how frequent it should be, how intense it should be, and so on?
Yeah, this is actually pretty much dependent upon the guide and you know, the likes and dislikes of the guide. But as a general rule, what I have tried to do is of course, you know, emulate what my PhD advisor did in our research group. What I try to do is I usually would like to meet with my research scholars on a daily basis.
Okay.
This does not mean that I expect them to make progress every day. Research is something, as someone said, research is something which where you have long periods of frustration interspersed with brief periods of elation.
Okay.
So the role of the guide is to prepare the student mentally for those long periods of frustration and teach them that, you know, this is a mindset, you know, you should not get frustrated. What is more important is the effort that you put in every day, day in and day out, rather than progress or lack thereof. So that is what research is all about. So I meet with the students every day, and most of the days the students will tell me, sir, I tried that, you know, it did not work, and we have discussions like that. So I tell them, yeah, don't worry about it, why don't you try this or keep trying. So in my mind, you know, this gives students the feeling that the guide is actually sympathetic and understands that, you know, the lack of progress is not due to a lack of effort, but because the problem is simply difficult. And it takes a while, you know, to figure out, otherwise it would not be research. That is the difference between doing research and doing project work. Project work, you have the problem, you know how to solve the problem, only the details have to be filled in. You do it, you get the answer. Whereas with research, many times the problem itself is not well defined, and you don't know how to actually solve the problem. You have a handful of options, hopefully, that you can try, and perhaps one of them will work out. But until that one works out, you have to go through periods of disappointment. So many people say frustration. I don't like that word. I prefer to use the word disappointment. You try something, it doesn't work out, you are disappointed, you want to try something else. So that would be a better way to look at research. How do you handle long periods of these kinds of trials and failures? That is the mindset that you need to develop. So I meet with the students on a daily basis only for that reason, that, you know, we have an interaction, the students feel happy that, you know, they have someone to talk to, and they can come to me they should not feel that they can come to me only to report successes. They should feel comfortable coming to me and reporting lack of progress. I won't call it failure, but I will say lack of progress. Okay. They should feel comfortable to come and say, no, it didn't work. Some students are very cryptic. They will say, no, it didn't work. Others would elaborate a little bit more. But whatever the students feel comfortable with, I would like to do that on a daily basis.
Very nice, very nice. So, see, when we talk of MS and PhD kind of degrees, people tend to think that, these are specializations. And in fact, that's the general perception that, it's a specialized degree. And it is. You specialize in a specific, problem associated with that general area of engineering or science. And then you come out with a degree. So, what sort of positions, in your view that you have seen, what sort of positions do these people who have done an MS or a PhD in mechanical engineering, what sort of positions do they tend to get once they graduate from the...
See, first of all, if you look at the kind of skills they are expected to acquire, I still remember attending a research meeting when I was a first year graduate student at Ohio State, and an executive from GM, was talking about how they make the decision to recruit either an undergraduate student or a master's student or a PhD student. And he said something very nice. He said, when we recruit a BTech student, we tell the student, do this. When we recruit a master's student, we tell the student, would you like to do this? When we recruit a PhD student, we tell them, what should we do?
Okay, very nice.
So these are the skills that the student should acquire. They should be able to answer these questions. With PhD or MS, which are both degrees based on research, you have two career options. One is to go into research and development in the Indian industry or any other place. R&D is definitely a very good option for them. And for students with both MS and PhD, these days there is a tremendous requirement for teachers in India today, because the number of colleges being so high, number of students studying engineering being so high, there is a tremendous requirement, and many universities and colleges from around the country do come to IIT Madras to recruit our students for such positions. So they can also look to a career in teaching. I think at the end of the program here, they should equip themselves well to go into one of these two career options, either career in research and development or a career in teaching.
Okay. So we now have some students who are probably considering, joining mechanical engineering for a higher degree and so on. So what are your words of advice for an aspiring student for higher education in mechanical engineering?
My word of advice to such students would be the following. Okay? You look at the options that you have. Many of these students actually will probably not be clear whether they want to do higher studies or whether they want to go for a job. Maybe they have a job offer. So my advice is, if you are trying to decide between the two, in today's world, I would almost always tell you that if you are able to secure an admission at IIT Madras for an MS or a PhD, you should definitely take it up, because it is a very enriching program. You have probably the best teachers in the world, and if you look at the rankings of the individual departments in our institute in IIT Madras, you will see that in QS ranking they are ranked among the top 100 departments in the world. So these actually it's a very good place to study, and whatever you did not learn in your undergraduate education, for whatever reason, you can probably compensate for that by pursuing a master's program here. And as the former placement advisor, I can also say that the employment opportunities that you would get at the end of your masters probably are the best that you can get in this country. The best companies come here for selecting, for example, companies like TVS Motors, Robert Bosch, General Electric, Rolls-Royce, NVIDIA, Texas Instruments, Eaton. All these companies come and recruit our masters, MS students from here. So you will have your shot at the best possible companies in the country. So you take this decision that you are grappling with now, whether you want to go for a job or higher studies, you take that decision. You are not really in a good position to take that decision now.
Okay.
Whereas after you get an MS from IIT Madras, you will be in a much better position to take that decision. You have a very good job that you have at your hand in one of the best companies in the country, and now you can decide whether you want to continue with that or pursue even higher studies like PhD and so on, and then go from there. So my position is you will be in a much better frame of mind, both academically as well as personally as well as professionally, to take the decision at the end of a master's program from IIT Madras. So my advice is, if you have an admission for MS in IIT Madras, don't even think twice, take it.
Okay, great. With those words of advice, we thank you very much for joining us.
Thank you, Pratap, for this opportunity.
For all the
Thank you for this opportunity. Thank you.